Gamma Cassiopeiae. Gamma Cassiopeiae, Latinized from G. Cassiopeiae, is a star at the center of the distinctive W asterism in the northern circumpolar constellation of Cassiopeia. Although it is a fairly bright star with an apparent visual magnitude that varies from 1.6 to 3.0, it has no traditional Arabic or Latin name. It sometimes goes by the informal name Navi. Gamma Cassiopeiae is a B star, a variable star, and a binary star system. Based upon parallax measurements made by the Hipparcos satellite, it is located at a distance of roughly 550 light-years from Earth. Physical properties. Gamma Cassiopeiae is an eruptive variable star whose apparent magnitude changes irregularly between plus 1.6 and plus 3.0. It is the prototype of the class of Gamma Cassiopeiae variable stars. In the late 1930s, it underwent what is described as a shell episode, and the brightness increased to above magnitude plus 2.0 and dropped rapidly to plus 3.4. It has since been gradually brightening back to around plus 2.2. At maximum intensity, G. Cassiopeiae outshines both a Cassiopeiae magnitude plus 2.25 and B. Cassiopeiae magnitude plus 2.3. Gamma Cassiopeiae is a rapidly spinning star with a projected rotational velocity of 472 km/s, giving it a pronounced equatorial bulge. When combined with the star's high luminosity, the result is the ejection of matter that forms a hot circumstellar disk of gas. The emissions and brightness variations are apparently caused by this decretion disk. The spectrum of this massive star matches a stellar classification of B0.5. A luminosity class of Roman 4 identifies it as a subgiant star that has reached a stage of its evolution where it is exhausting the supply of hydrogen in its core region and transforming into a giant star. The E suffix is used for stars that show emission lines of hydrogen in the spectrum, caused in this case by the circumstellar disk. This places it among a category known as B stars, in fact, the first such star ever to be so designated. It has 17 times the Sun's mass and is radiating as much energy as 34,000 suns. At this rate of emission, the star has reached the end of its life as a late O-type main sequence star after a relatively brief 8 million years. The outer atmosphere has an intense effective temperature of 25,000 K, which is causing it to glow with a blue-white hue. X-ray emission. Gamma Cassiopeiae is the prototype of a small group of stellar sources of X-ray radiation. The character of the X-ray spectrum is B-thermal, possibly emitted from plasmas of temperatures up to least 10 million kelvins, and shows very short-term and long-term cycles. Historically, it has been held that these X-rays might be excited by matter originating from the star, from a hot wind or a disk around the star accreting onto the surface of a degenerate companion, such as a white dwarf or neutron star. However, there are difficulties with either of these hypotheses. For example, it is not clear that enough matter can be accreted by a white dwarf at the distance of the purported secondary star implied by the orbital period, sufficient to power an X-ray emission of nearly 1033 erg/s or 100 YW. A neutron star could easily power this X-ray flux, but X-ray emission from neutron stars is known to be non-thermal, and thus in apparent variance with the spectral properties. Evidence suggests that the X-rays may be associated with the B star itself or caused by some complex interaction between the star and surrounding decretion disk. One line of evidence is that the X-ray production is known to vary on both short and long time scales with respect to various UV line and continuum changes associated with a B star or with circumstellar matter close to. Moreover, the X-ray emissions exhibit long-term cycles that correlate with the light curves in the visible wavelengths. Gamma Cassiopeiae exhibits characteristics consistent with a strong disordered magnetic field. No field can be measured directly from the Z-min effect because of the star's rotation-broadened spectral lines. Instead, the presence of this field is inferred from a robust periodic signal of 1.21 days that suggests a magnetic field rooted on the rotating star's surface. The star's UV and optical spectral lines show ripples moving from blue to red over several hours, which indicates clouds of matter being held frozen over the star's surface by strong magnetic fields. This evidence suggests that a magnetic field from the star is interacting with the decretion disk, resulting in the X-ray emission. A disk dynamo has been advanced as a mechanism to explain this modulation of the X-rays. However, difficulties remain with this mechanism, among which is that there are no disk dynamos known to exist in other stars, rendering this behavior more difficult to analyze. Companions. Gamma Cassiopeiae has two faint optical companions, listed in double star catalogues as components B and C. Star B is about 2 arcseconds distant and magnitude 11, and has a similar space velocity to the bright primary. Component C is magnitude 13, nearly an arcsecond distant. Gamma Cassiopeiae, the bright primary, is itself a spectroscopic binary with an orbital period of about 203.5 days and an eccentricity alternately reported as 0.26 and near zero. The mass of the companion is believed to be about that of the Sun, but its nature is unclear. It has been proposed that it is a degenerate star or a hot helium star, but it seems unlikely that it is a normal star. Therefore, it is likely to be more evolved than the primary and to have transferred mass to it during an earlier stage of evolution. Names. The Chinese name C, the Wip Chinese C, pinyin C, is commonly associated with this star. The name, however, originally referred to Kappa Cassiopeiae, and Gamma Cassiopeiae was just one of 4 horses pulling the chariot of legendary charioteer Wang Ling. This representation was later changed to make Gamma the Whip. The star was used as an easily identifiable navigational reference point during space missions, and American astronaut Virgil Ivan Gus Grissom nicknamed the star Navi after his own middle name spelled backwards.